All right, so today's lesson is going to include both lesson 1.9 and 1.10. So 1.9 is all about writing formulas, and the formulas on this sheet are formulas you should already know, except for maybe a regular polyglot. Okay. And what we're doing is it's very short. I only have 5 phrases that we're going to look at, and we're going to read it to come up with the actual formula that applies to what it's talking about. Okay, so let's go ahead and go to example 1. Now, a lot of times you can just write the formula as you read it. So we have our first example. The area of a square is 1 side squared. So if I were to pick apart what this is saying, I would write A for area is equals 1 side is S and then squared. So sometimes it's as easy as just writing the letters and the numbers that the sentence says in the order that it says it. So I would write this as area equals side squared. Okay. Let's go to example 2. The distance traveled D is equal to the rate of speed R multiplied by the time T spent traveling. So I'm just going to go through and fill in the numbers and the letters that it gives me and the symbols. So the distance traveled D is equal to the rate of speed R multiplied by time. Well, that was easy. Distance equals rate times time. Look at this. The Celsius temperature C, so we know we're going to start off with C, is equal to 5/9 of the difference. Okay, anytime that you see of the difference of 2 terms, so here we have the difference of Fahrenheit and 32. You're going to put those in parentheses. Okay, so we're going to start our parentheses. The difference means that we're going to subtract those 2 terms. So this would be an example of how you can't write it exactly how it's written. So we're going to write the difference of Fahrenheit and 32. So how would we write that? F minus 32. So we have F minus, and then we have 32. Okay, and then end your parentheses. So our final answer would be Celsius is equal to 5/9 of the difference of Fahrenheit and 32, just like that. And some of these you already know the formulas too. So, okay, this one is a little bit different. So a lot of times when you're looking at a statement that isn't a formula, but it's a real world situation, then you're going to have to think about it. And sometimes you have to read and reread and reread for it to make sense. So let's read this and then let's discuss it. State the number of seats A in an auditorium if there are X rows and Y seats per row. Now I want you to think about this as this is our stadium in the classroom, and we have all 4 of these rows right here. Okay. How would we, without counting each desk, know how many desks there are based on X rows and Y seats, or X seats and Y rows? How would we figure out how many seats are? And what would we be multiplying? The rows and the seats. We would be multiplying the number of rows times the number of seats in a row. Okay, so how would somebody besides Austin and Rain want to tell me how we would write this equation? Okay, XY. A equals X, the number of rows, times Y, the number of seats. Now, what does this formula look like? Yeah, length times what? The length of here is 4 desks. The length of here is 4 desks. 4 times 4 is 6. Oh, right, that's right. Okay, now this one is even more different. State the cost C in cents for a 10-minute telephone call if the charge for the first 3 minutes is X cents and the charge for each additional minute is Y cents. Okay, we don't have cell phone bills that charge like this anymore. But when I was younger and cell phones were first coming out, we had this big Brook-like phone with a long antenna, and it was push button, and it was big and bulky, and we didn't use it very much because we couldn't afford the charge. It was like 10 cents a minute to use the phone. So for one phone call, well, your phone charges could add up to a lot of money. So anyway, but it's not charged like that, it's a flat rate. But what I want you to do is I want you to read this with your partner, and I want you to try to figure out what the equation might be, because I'm not going to be there, right, with you as you do your homework, and I need you to be able to think about it and try to reason and figure it out. Okay, so I'm going to give you about 2 minutes to do this, and then we're going to share out what we got. So go ahead and work with the people around you. And I'm going to pause the video while we do this. Okay, so just to explain, we have a total of 10 minutes of a call. 3 of those minutes is going to cost us X cents. So if it costs us 25 cents, we would multiply 3 times 25 and we get 75 cents. But we don't know what the cents are, so it's going to be 3 times X. But then all the rest of the minutes out of the 10, so we've used up 3 minutes, so we have 7 minutes left. All of the rest of the minutes is going to cost Y cents. So you should get this equation, C equals 3 minutes times a certain number of cents, and then 7 minutes times a different amount of cents. And so that's your equation. Okay, your homework for 1.9 is all the blue flag practice and review. So now we're going to move on to lesson 1.10. So let's go ahead and go to this lesson.
What's our last lesson?
This one.
Wait, for
There we go.
chapter 1.
Yep, for chapter 1, this is our last lesson.
Thanks.
Okay, so lesson 10 is properties of algebra. You've been dealing with properties of algebra for the past 2 years. I know that is part of the Rebecca curriculum in 7th and 8th grade, but sometimes we need to be reminded of it. So I'm going to go through each of the properties up here in the chart, and then I'm going to have you work with your partners to try to do the problems at the bottom of your notes. So commutative property of addition and commutative property of multiplication. No matter what your order is of your numbers, you can still perform the operations. So for example, 2 plus 5 is the same as 5 plus 2. Or 2 plus 5 plus 3 is the same as 3 plus 2 plus 5. Okay? It's the same. It doesn't matter how you add them, you will always get 10 on both sides. Okay? Now, sometimes you will see parentheses around it. But what you need to know is that if the numbers are out of order on each side, they're not the same order, it's always going to be different. Multiplication, we have -3 times 8 is the same as 8 times -3. It's also the same as -3 times 8 times 2 equals 2 times -3 times 8. It does not matter the order you multiply them, you will always get the same answer. And in this case, it's -48 on both sides. So that's commutative property. Okay. Let's go to associative property. We have associative property of addition and multiplication. This has to do with groupings. So if you wanted to, you could put order. That's how I tell the difference between commutative and associative. Associative property has to do with the grouping of your numbers. Okay, so -3 plus 5 plus 2 is the same as -3 plus 5 plus 2, but the groupings are just different. Here, they're grouping -3 and 5. Here, they're grouping 5 and 2. So it's the same order of numbers, but the groupings are different. Okay, so here you're gonna put same order, but different groups. Okay, and that goes for both multiplication and addition. So here, associated property of multiplication, the numbers are in the same order, 2 times 4 times 6. But here, they're grouping 2 and 4, and over on the other side of the equation, they are grouping 4 and 6. So commutative is about order, where both sides are mixed up. Associative is about grouping. So let me show you something really quick on the back. Okay, what if I had 2 plus 8 plus 15? And then 15 plus 2 plus 8. What is that? It's commutative. Okay, what if I had parentheses here and parentheses here? It's going to be commutative. So even if there are parentheses, what you always need to do is you need to check the order. If the order is mixed up with multiplication and addition, it's always going to be commutative, even though there are groupings here. Okay, it will always be commutative first. Okay. All right. Let's go back. Now we have the distributive property. Here you have -3 times -4 plus 5. This is if a number is right outside the parentheses. Okay. Sometimes it might look like this: -3 times -4 plus 5 equals -4 plus 5 times 3. So it could look either way, it's still the distributive property. Here up at the top, they went ahead and distributed it. Here they didn't distribute it, they just, that's not distributed it. Anyway, they just moved the -3 over, and I forgot my -3 over here. Okay. Now we have 2 identity properties, one of addition and one of multiplication. And the key is, when I think about this, is that whenever you have a number added to something else and it equals that same number, that's an identity. It matches. My identity here matches my ID card on my driver's license. Eventually, you guys will have one of those if you don't already have it. So the addition of the identity property is adding 0. Okay. The multiplication of identity is multiplying by 1, because when you add 0 to any number, it keeps that same number as the answer. When you multiply any number by 1, it keeps that same answer, that same number in here. Okay. So identity property of addition is adding 0. Identity property of multiplication is multiplying by 1. Okay. Inverse property. When you take a positive number and you add it to its negative or its opposite. So +6 plus a -6, you have 6 positives and 6 negatives, they cancel each other out. And your answer will always be 0. That's what the inverse property of addition is. Let me show you something really quick. I'm gonna add one over here. The inverse property of multiplication. And I want you to add this here. Okay. This is when the multiplication, inverse is 1. So for addition, it's 0 additive inverse. For multiplication, it's a multiplication inverse of 1. And it would look like this: 6 times 1/6. What does 6 times 1/6 equal? It equals 1. It's the same as 6 over 1 times 1 over 6. And you get 6 over 6, which equals 1, right? So we have two inverse properties. We have one of addition, meaning that when you add its opposite, you get 0. And we have one of multiplication. When you multiply its reciprocal, you get 1. Or another name for reciprocal is its inverse. You invert the number from 6/1 to 1. And then the last one, 0 property of multiplication. Anytime you multiply something by 0, you get 0. So this is multiplying by 0. Okay. Any questions about any of that? Okay. Yes. So what I want you to do is I want you to work with your partner or the people around you, and I want you to try to figure out which property these are representing. Do not forget to put the property of addition or multiplication. So commutative property of addition, commutative property of multiplication, and you can't abbreviate. Okay, so COM add, COM mult, and so on. Yes.
Like inverse of division.
Yeah. You can even put ID, like the letter I-T of whatever it is. Okay.
I want to abbreviate associative 3 letters, right?
ASSOC.
Yeah.
Yes, you can do that. All right, I'm gonna pause the video while you try to work on this, and then when I bring the video back, it will we'll go over the answers. Okay, so this first one, remember I said that if there is a number right outside the parentheses, it's distributive, and they did distribute the 3 to get 3x plus 15. So this is the distributive property. Okay. This one again is very similar to the one that I wrote up here, that you can just reverse it. It's still distributive, but it can also be. No, it's distributive. I'm sorry. I was going to say associative, but it isn't because here, distributive property. I lost my train of thought. Or the groupings are the same, but the order is different. So it could be commutative property. Yeah.
Okay, that's what I.
Yeah, it could be both. Okay, it could be both. All right, the next one. It could be distributive property, but what else could it be? Commutative property, so it could be both.
What if it is both on the homework?
I will take either one.
Okay. You give one spin for both.
Maybe.
That's a problem.
Okay, next one, let's see, we have 3x5, 3x5, so it's in the same order. So it's not commutative, but our groupings have changed, which means it is
Associative binary.
Yeah.
Oh.
Yeah. Good. All right, so number 5, 3x5, x5, 3. What is this one? No, remember when the numbers are out of order, it's commutative.
It's property of addition.
Mhm. All right, 7x plus 3, 3 plus 7x. Yeah, more commutative property. Commutative property. So just out of order, you could still add them and get the same answer. Okay, this one. We have 7 positives, 7 negatives. It wipes it out to a 0, which is
Inverse property of addition.
yes, inverse property of addition. Okay, 7 times 1/7 is 1.
Okay.
Inverse of multiplication, good, because we inverted the 7. Inverse property. All right, 8 plus 0 equals 8. It keeps its identity. So identity property of addition. All right, this one's different. Okay, well, let's look. We have CDF, CDF. It's in the same order, so it's not commutative. So it is associative property.
Oh, it's multiplication.
Yep. All right, good. Okay, so that concludes lesson 1.9 and 1.10.